Hi, hello everyone. Welcome to Secondary School Chemistry with Mr. Kelechi. All right, in view of the forthcoming WASSCE Alternative B quantitative analysis practical, this is the first part of possible questions you might see on the titration practical, right? And remember, we learned or we are rumored that the practical will be a redox titration practical, not an ordinary acid-based titration practical involving an oxidizing agent and a reducing agent. Now, let's see possible questions that might come up in that particular exam. Now, the question I have here, now listen, number one, the question it says, solution D is a solution of 3.6.3 gram per dm cube of oxalic acid X hydrated, an unknown value of the hydrate X hydrated. Solution E is a solution containing 3.1 gram per dm cube of KMnO4 solution. After the titration, 24.5 dm cube of D was obtained at endpoint. Now we are given the equation of the reaction and we are asked to calculate this. Number one, calculate the concentration of E in mole per dm cube. Question 2, calculate the concentration of D in mole per dm cube. And question 3, calculate the concentration of the oxalic acid, the anhydrous oxalic acid without the water of crystallization of D in gram per dm cube. And you should find the value of X in the oxalic acid. Now, this is what is simply explaining that D is an oxalic acid, which is this, X hydrated, an unknown value of the hydrate, right? And E is KMnO4, an oxidizing agent. Now we are given the equation of the reaction. I'll just write out the ratio of it. This 5C2O4 2 minus of the oxalic acid ratio 2MnO4 minus. Now, this is the balance equation of that. If you are wondering how I got balance equation, you can simply check my previous video. I explained how to write the balance equation in a redox titration. So you can better go and check it out to understand better. Now, the first part of it, we are asked to calculate question 1, the concentration of E in mole per dm cube. Now, whenever we hear mole per dm cube, the first formula that comes to our mind is our CAVA formula. But in this case, they said the solution is D and E. So it's going to be our CD, concentration of the D, and the concentration of the E. We know it as CAVA formula. But our CAVA formula cannot work if we are not given the concentration of one particular entity. Now, if you look at the equation very well, we are not given the concentration of any of them. Neither we are given the concentration in mole per dm cube of this or the mole per dm cube of that. We are only told the mass concentration of the both of them. Now, how do we go about it? Simply, we know that molar concentration in mole per dm cube is equal to concentration in gram per dm cube all over the molar mass of that substance. Now, we can calculate the molar mass of E, which is KMnO4. We can also get the mass concentration from the question, which is 3.1 gram per dm cube. Now, if we simply do that, the molar mass of KMnO4, we know that potassium is 39 plus manganese is 55 and oxygen is 16 times 4. And if you sum up that, that simply gives us 158 gram per mole of the KMnO4. So molar mass is 158 and our mass concentration from the equation is 3.1. If we simply do that, our concentration of E in mole per dm cube, if we divide that, let's simply divide that, it's going to give us 0.0196 mole per dm cube of the KMnO4. So we've gotten our concentration of E in mole per dm cube. Now the second question we have here is that we should calculate the concentration of D in mole per dm cube. Concentration of D in mole per dm cube. Right? Now, How do we do this? Remember I said whenever you have a calculation on concentration in mole per dm cube, the first thing that comes to our mind is our CAVA formula, right? So that is what we have. Now in this case, we are given the concentration of one person, so we can calculate the concentration of the other. But in this case, it's not the CAVA, it's going to be CD, concentration of D, which is the oxalic acid, times the volume of D all over the concentration of the E times the volume of the E equal to the ratio of them, number of D all over number of E. Now, what is our concentration of the D? That's what we asked to find. Our volume of the D, our volume of the D is the D that was obtained at endpoint, and we are told that it is 24.5 cm3 that was obtained after the titration. And our VE is the volume of the pipette size, 25 cm3. And our CE, concentration of the E, this is what we have here. And the ratio between D and E, ratio between D, E is this and D is that. So this is the ratio between the 5:2. Now let's make this man the subject of the formula. We simply do that. CD will be equal to CE times VE times ND all over VD times NE. Now we simply plug in all our parameters there. We are going to get our CE, concentration of the E, 0.0196 times our volume of the E, volume of E, our pipette size, 25 times our number of D, these are D, our number of ratio of D is 5, all over our volume of D that was obtained at the endpoint is 24.5 cm3 times our number of E, which is the KMNO4 is 2. If we simply multiply and divide that, we will simply get 0.05 mole per dm cube of D. Very straightforward, right? So this is our concentration of D. Now the next question there says that we should calculate the concentration of the anhydrous oxalic acid without the water of crystallization. Now, this is the first part of it. In our next video, we'll talk about that. Have a nice day and see you in the next one.